In the modern timber industry, there is no such thing as waste. Every wood fragment becomes energy, and every plank becomes inspiration. Today, join RaWMachines as we witness an impressive closed-loop process. From the classic standing board logging method, through strict moisture control at the sawmill, to the revival of 12th century wooden ship designs. This is not just manufacturing, it is a journey that carries wood from the earth back to the ocean. Let's begin. There was once a time when the American timber industry thrived, but was accompanied by significant waste. Over 70% of each tree's value went unused, left behind or becoming a potential cause of wildfires. Today, everything has changed. Sustainability is no longer an option, but a mandatory requirement. Thanks to advanced technology, timber resources are utilized to their maximum potential. This is not just a technical improvement, but an affirmation of responsibility in preserving resources for the long term. Now, let's return to Bjarne Butler's logging process. The centerpiece of this video is a giant western red cedar with a base diameter of nearly 2.5 meters. What makes this task incredibly difficult is its growing position. The tree is rooted directly onto a large rock and has a very complex, flared base. To handle this, the logger must employ the classic springboard technique, a skill that demands both courage and absolute balance. Standing more than 5 meters above the ground on narrow boards, the logger relies solely on the strength of his arms and the sharpness of the chainsaw to subdue this green giant. First is the V-shaped undercut, which determines the intended direction of the fall. Next is the back cut. The long saw blade sinks deep into the ancient timber. The logger must observe the vibration and lean of the tree with extreme care. Finally, the trunk detaches from the stump, crashing down with a terrifying force of inertia, creating a sound that echoes throughout the forest. Once the tree has fallen, the arduous journey of the logs truly begins. Depending on the terrain, various transportation methods are applied to ensure efficiency and safety. In steep and rugged areas, cable systems become the optimal solution. Steel cables connected to winches or cranes pull the timber up the slopes, traversing terrain that motorized vehicles cannot access. When the terrain is less rugged, specialized skidders are mobilized. With powerful grapples or winch cables, they decisively drag the logs across the ground. In some areas with rivers and streams, people take advantage of the natural current. Logs are floated downstream or tied into rafts, moving with the flow to the collection point. This method is low cost and can handle large volumes. Finally, when long-distance transport is required, trucks and trailers take the lead. These loads of timber move from the forest to the mill, where the next journey begins. The destination in this case is a modern sawmill in South Carolina, where technology and engineering combine to transform raw materials into high-value products. Every truck entering the company gates must pass through a weigh station. The vehicle is weighed while fully loaded and weighed again after being completely unloaded to determine the delivered timber volume, typically around 26 tons per trip. The logs are then transferred to the log yard or directly onto the infeed deck. This area functions as a buffer storage, ensuring that the production line remains uninterrupted, even if the next truck has not yet arrived. Leaving the processing deck, the large logs are fed into the debarker. In just a few seconds, the rough outer bark is completely stripped away. The bark is collected and repurposed rather than discarded. It can become fuel for boilers or materials for landscaping mulch. In this way, everything is fully utilized, reflecting the factory's commitment to sustainable production. Next, the logs can follow two paths, to the DLI twin saw or the carriage saw. Let's follow the carriage saw first. For logs with large diameters, typically over 1 meter, a carriage saw system is utilized. The logs are placed on a carriage that moves steadily past a razor-sharp band saw blade. Before the blade makes contact, a laser scanning system analyzes the log's shape to determine the optimal cutting positions, ensuring the highest recovery of high-value timber. After the initial pass, the slabs proceed to a resaw station, where they are further processed into smaller, precise dimensions. In parallel, small and medium-sized logs are processed by a different system, the DLI and reducer twin. Right from the start, these logs are milled on two sides to create a squared-off cant, making it easier to orient them for the subsequent steps. The wood removed during this process does not disappear. Instead, it is converted into wood chips, a commercially valuable product used in many other industries. The highlight of this process is the curve sawing technique. This is a breakthrough compared to traditional industrial thinking. Instead of cutting straight as in older methods, which reduced efficiency and quality, this system allows the saw blades to flexibly follow the natural curve of the log. As a result, production efficiency is significantly improved. The boards are longer, the recovery yield increases, and defects such as warping or cracking are minimized. This is the clearest testament to the integration of modern technology and the philosophy of sustainable harvesting. After the primary cutting stage, the boards still have wane edges and rough surfaces. At this point, the edger takes over, trimming away the excess to create straight, uniform, and neat edges. The removed wood is not wasted but is repurposed as wood chips for the paper industry or as biomass fuel. Next is the cross-cutting stage using the trimmer system. No longer natural, long logs, each board must now adhere to standard dimensions suitable for construction and manufacturing needs. An automated system calculates and selects the optimal cutting positions, helping to remove sections with defects such as dead knots or cracks, while retaining the best quality wood. The arduous journey is not yet over, as moisture remains the deciding factor. To prevent warping and cracking, an automated system sorts and stacks the boards, placing small stickers between the layers to allow for air circulation. Afterward, the entire load is moved into industrial kilns. This is a critical stage that lowers the moisture content to a standard level of 10 to 15%, ensuring the durability and stability of the wood. Only when the necessary dryness is achieved is the product truly finished in terms of quality. When leaving the kiln, the lumber is moved to the planer mill. High-speed blades process all four sides, creating a smooth surface and ensuring the wood meets precise dimensional standards. Beyond traditional lumber, the sawmill industry is embracing a new philosophy: zero waste. Advanced production facilities, such as Columns Lumber, are leading the way in repurposing and innovating with every byproduct, transforming scrap into valuable resources and minimizing environmental impact. Mulch. Wood waste can be ground into mulch for landscaping and gardening. It helps retain soil moisture, suppresses weed growth, and adds aesthetic value to green spaces. Wood pellets. Scraps too small for traditional manufacturing are compressed into pellets, serving as a sustainable biomass energy source that replaces fossil fuels in heating and power generation systems. Sawdust. This common byproduct is repurposed into charcoal briquettes, an eco-friendly alternative to traditional charcoal, or used as animal bedding to provide a dry and comfortable environment for livestock. This approach is more than just a cost-saving measure. It is a profound respect for resources and a strong commitment to sustainable forestry. Every board carries its own grade stamp. This is a mark of prestige and reliability, clearly specifying the wood species, load-bearing capacity, and the manufacturer's identity, acting as a firm commitment to every customer. Finally, the finished boards are gathered into bundles, secured tightly with steel or plastic strapping, and wrapped in protective layers to ensure safety during transit. These bundles of timber are now loaded onto rail cars and trucks, embarking on a new journey. Their destination is the Stjern Shipyard in Norway, where they are transformed into the vibrant hulls of Nordland boats. The video opens with artisans Harold Rons and Ole Jan Horstad arriving at the shipyard. They begin by studying the detailed technical drawings of Hans Severin Berdahl from 1937. This is a crucial step to ensure the historical authenticity of the Nordland boat lineage. The real work begins with processing the keel for a large fembering. Using axes, the craftsmen hew large pine blocks to create the necessary bevels. Each stroke is decisive yet refined, shaping the sturdy pine to form the stem and stern, preparing them for the first mortise joints. Next comes the adjustment of the hulls. This is the junction where the keel meets the hull planks. Here, even the smallest deviation can compromise the entire structure. Consequently, every movement demands near absolute precision. The hulls is carved from solid wood without fixed templates. The shipwright must rely on experience to feel the grain, guide the chisel, and create the proper curve. This curvature isn't just aesthetic, it determines the boat's hydrodynamics. A perfectly crafted hulls allows the vessel to glide smoothly and remain stable when facing wind and waves. The distinction between vessel types becomes clear at this stage. For the smaller fairing, the hulls is sleeker and less complex, reflecting its agility. In contrast, the large fembering requires a much thicker and more precise structure to withstand greater forces and maintain balance for the massive hull. Traditional tools are used throughout. Wooden clamps, known as slappen, hold components in place, while specialized gauges help control the subtle curves. Without the aid of modern machinery, everything depends on the hands and focus of the craftsman. contrast here is striking. From raw, heavy timber, soft and precise curves gradually emerge. The shipwright isn't just processing material, they are transforming it, turning the roughness of nature into the geometry of motion. Once the transition pieces are perfected, the boat enters the expansion phase, where the individual planks are attached to form the actual hull. The second strake is installed first, secured beneath the rema to provide a foundation for subsequent layers. Then, the third strake is positioned above it, gradually raising the sides of the vessel. These planks are not light. At approximately 25 millimeters thick, they are stiff and difficult to bend. To force them into the desired curve, the craftsman must use significant physical strength combined with timber props to hold the planks in position until they are set. Precision is vital in this stage. Both sides of the hull must be perfectly symmetrical, not just for aesthetics, but to ensure balance during operation. The builders constantly check the continuity with measuring sticks, reviewing every curve and joint. Once the strakes are in place, the internal ribs are fitted. These frames reinforce the hull and help it maintain its shape under water pressure and heavy loads. They are secured using wooden tree nails, a traditional but highly effective method. No metal, no complex machinery, just wood joining wood to create a structure that is both rigid and flexible. As the final plank of this stage is secured, the transformation is evident. The boat has truly stood up. While not yet finished, its shape, proportions, and latent strength are clearly visible, like a living being slowly waking up. Structural completion and exterior form. As the hull takes shape through the initial strakes, the work moves into the phase of structural completion. The subsequent planks are installed in succession, the fourth, the fifth, and finally the topmost strake, the ripscot. This is not merely the final layer, it is a protective boundary crafted from solid timber to enhance the durability and load-bearing capacity of the entire hull. At this stage, the iconic silhouette of the boat becomes more apparent than ever. The vertical, sharp stem posts stand out, an unmistakable hallmark of this craft. Beyond aesthetics, this design reflects maritime wisdom accumulated over generations, where every detail serves a specific purpose in harsh sea conditions. Once the outer shell is complete, a meticulous inspection is conducted. The project management directly evaluates every detail, from the curvature of the hull to the integration of the components. This is the moment of reconciliation between reality and the 1937 blueprints, reaffirming that the boat is not just being built, but resurrected. Next is the installation of the crossbeams, or bait, key bracing elements that link the entire structure. These are made from spruce, often utilizing the natural curves of the roots to ensure inherent strength and the correct anatomical arc. When set into place, these crossbeams do more than reinforce the hull. They lock the entire structure together, creating a unified and robust frame. The contrast between the beginning and the present is now stark. From fragmented raw timber, a complete structure has emerged, possessing form, proportion, and power. The boat is no longer just an idea, it is a reality, bearing the imprint of both tradition and human skill. Interior, finishing, and traditional knowledge. With the primary structure finished, the work moves inward, where small details begin to define the soul of the vessel. Interior components are carefully fitted. The gunnel planks provide a sturdy rim, the mast step takes its central position, and the seating planks are installed to ensure balance and functionality during operation. Hidden within are subtle details, such as the small wooden shims crafted by Harold, placed between the ribs and the crossbeams. Though nearly invisible, they reduce friction and increase stability, clearly demonstrating traditional knowledge gained through experience rather than formal drawings. The final stage is the painting, where the boat takes on its cultural identity. The gunnels are painted green, a nod to its forest origins, while the white splashboards provide a crisp accent against the water. From a raw structure, the boat is now complete, not only sturdy, but possessing its own identity, ready to leave the workshop and face the vast ocean. The Gislinge boat project is more than just building a wooden vessel. It is an effort to bridge a gap of nearly 900 years of history. From an archaeological relic buried deep in Danish soil, 12th century designs have been revived through a modern mindset. Open source. In this time-lapse footage, we witness Chesapeake Lightcraft bringing the project to life by creating a 33% scale model. The most unique aspect of the process lies in the intersection of classic Viking shipbuilding techniques and the contemporary stitch and glue method. Rather than hewing giant oak trunks, the engineering team uses marine-grade plywood cut with absolute precision via CNC machines. The project's greatest challenge was retaining the soul of the ancient ship, those elegant, overlapping lapstrake planks, while simplifying the process so an amateur builder could replicate it. Through each frame, we see the patience required to join the wooden panels and the meticulous use of clamps to shape the complex curves of the hull. Building this small-scale model is a vital testing phase. It allows experts like Jay Hockenberry and Andrew Schroer to verify the feasibility of the assembly kits before they are released to the public. The significance of the project extends far beyond a shipyard in the United States. By digitizing and sharing the blueprints, Chesapeake Lightcraft and the Viking Ship Museum have transformed a cultural heritage into a living document. This process not only honors the skills of ancient master shipbuilders, but also empowers today's generation, making the act of owning and hand-building a Viking boat no longer an impossible dream. Once again, the Viking spirit of exploration is ignited, not on the high seas, but within family wood shops. So, we have just completed a long journey, the journey of a tree, beginning deep within the vast forests of North America. From those raw timbers, we witnessed an impressive transformation inside modern sawmills. Logs are no longer merely raw materials. They have become data for machines to analyze, calculate, and extract maximum value. The old concept of waste is gone. Bark becomes biomass fuel, wood chips serve the paper industry, and sawdust is compressed into energy pellets. A nearly closed loop is emerging, where economic efficiency goes hand in hand with environmental responsibility. But perhaps the most extraordinary part of this entire journey lies at its destination. In the end, those boards become more than just inanimate construction materials. They find their way into the hands of boat builders in Norway, where traditional craftsmanship is preserved with the same spirit held hundreds of years ago. There, amidst the sound of hewing axes and the scent of pine resin, the curves of a Nordland hull emerge, not through automated assembly lines, but through the eyes, hands, and experience of humans. This contrast creates something truly special. On one side, modern technology optimized to the millimeter. On the other, manual artistry guided by feeling and intuition. Yet, instead of displacing one another, they complement each other to create a complete value. Ultimately, what this story leaves behind is not just images of giant machines, massive trees, or beautiful boats. What remains is the way humanity is gradually shifting its relationship with nature, from extraction to preservation, from consumption to regeneration, from waste to optimization. From materials that seem inanimate, humans have created products that carry the history, culture, and spirit of many generations. A tree may take hundreds of years to grow, but when used correctly, its value can live on for hundreds of years more, in homes and structures, or within the hulls of ships that continue to brave the open sea. Thank you for listening to the end of the story. If you enjoyed this video, please like, share, and subscribe to the channel so you don't miss our next stories. RaWMachines says goodbye, and we'll see you again soon.